I just hear some feedback. I just unmute someone here. So, hello everyone, and thank you so much for joining us this evening. My name is Christopher Hardy, and I'm the co-director of Formlab and tonight's moderator. I'm joined with my fellow co-director, Adrian Chu, who will be monitoring the chat bar of this event. On behalf of the Formlab team, I would like to welcome you all to our first ever digital research symposium called Forum, which begins today and will continue until tomorrow evening. As a research and design collective at the University of Waterloo, Formlab is engaged in the exploration of advanced computational design tools. We provide an ongoing platform for peer-to-peer learning and collaboration to explore the potential of interactive art, technology, and architecture. This year, we are holding our inaugural forum on the intersection of architecture and emerging technologies. We hope to spark discussions between current students, faculty, alumni, and professionals to broaden the discourse around computational and technology-driven designs. Given the remote nature of this event, and that we are all situated in different parts of the world, Formlab is a student group at the University of Waterloo School of Architecture, and as such, we acknowledge that we live and work on the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. The University of Waterloo is situated on the Haldeman Tract, the land promised to the Six Nations that includes 6 miles on each side of the Grand River. We'd like to remind you that these sessions will be recorded and published online on our YouTube channel to serve as a learning tool for future students. Please ensure your microphones are on mute for the duration of each presentation. Tonight, we will have 4 wonderful speakers who are faculty members and graduates of the University of Waterloo School of Architecture, and each will present for 20 minutes, roughly, followed by a 10-minute question and answer session. At the end of the night, we'll have a panel discussion with all speakers. You can ask a question by typing it out into the chat bar located on the bottom right of your screen, or by unmuting yourself during the question periods. We ask that you hold your questions during the Q&A or the panel sessions. Without further ado, I would like to introduce our first speaker, Maya Pereski. Maya is an associate professor and associate director of undergraduate studies at the University of Waterloo School of Architecture. She's also the director of Data Lab, a research group at the school. A graduate of the University of Toronto's Faculty of Architecture, Landscape and Design, and the Department of Computer Science, Maya's work focuses on the intricate overlap between architectural design, data, and computation. She has received numerous awards for her work, including the Royal Architectural Institute of Canada's Medal for her thesis work on post-oil opportunities for the Caspian Sea in 2007, and a grant from the Social Sciences and Humanities Research Council of Canada for her soft materials project in 2018. So Maya, please take it away.
Great. Hi, everyone. I'm just going to set up my screen share for a moment, so bear with me. You see an intro slide?
Yep.
Awesome. Okay, cool. Great. So thanks to everybody and Christopher and Adrian for the Formlab invite. I'm really excited to be here to kind of share my ongoing work, specifically entitled Embracing a Material Turn in Software Embedded Design. I'm also looking forward to hearing the other presentations, and it's really awesome to see Alice on the stage tonight, and I also saw some former Data Lab colleagues join the call today, so it's nice to see everyone again. I should mention that the work I'm presenting was done on a research team. A research associate, Cam Parkin, was part of the group, and research assistants Alice Wang and Vincent Min were also part of the team. The work is also supported by the Social Science and Humanities Research Council of Canada for the project that you mentioned, the Soft Materials Project. So I'm first today, and so I want to be really respectful of time and basically try to set a good precedent for everyone else to keeping on time. So I've organized this short talk into 2 parts. The first part will explore how a material turn in our relationship to digital media points to new obligations for something I call software embedded design. And the second part introduces a kind of project anatomy framework, so a kind of new lens through which to analyze software embedded design projects in light of these new obligations. So first things first, I mentioned the research focuses on software embedded design. And this is a kind of growing practice that I'm particularly interested and engaged with. And it's a practice that I identify as kind of a marked increase carried out by architects to increasingly bundle digital components with physical assemblies together in their pursuit of what they might call a responsive or a sentient, an adaptive, or heaven forbid they use the dirty word smart architecture. So software embedded design projects are incredibly wide-ranging. They offer a ton of different formats and everything from immersive experiences, participatory platforms, etc. And I see them really right now kind of still a nascent state where they're often led by kind of academic research environments. They're usually more installations rather than permanent fixtures. And there's usually a lot of kind of experimentation and kind of exploration through materials and things like that in these works. But at their core, these architects actively explore the relationship between materials, form, data algorithms, and their joint capacity to organize and mediate the built environment. And so this practice really transforms digital elements into persistent, active agents charged with continuous mediation of a project's functioning in time and space. And so what does this kind of persistent agency mean for architects' relationship to these embedded computational components? And so for one, I think it's really important to note that they're no longer design tools, which is often how we think about digital technology within architecture. They're not tools that basically help with work done while in studio or in a fabrication shop, but rather, more like materials, they directly shape the ongoing impacts, experience, and performance of the project. So as such, I argue that these kind of software embedded elements, such as data, algorithms, code implementations, they should not be decoupled through a kind of perceived immateriality from a project's physical dimension. And instead, they should be thought of as soft materials, which is a term I use to kind of describe in the foreground these things that I mentioned, such as data, algorithms, and code implementations, as materials in and of themselves, and thus explicitly constituting part of the project's material assembly. And so what I'm sorry, those are my kids, I'm sorry for that. What I'm trying to kind of get at is there's a kind of material-oriented perspective of digital media that operates in worlds of kind of media theory and science and technology studies and things like that, that really kind of reinforces the idea of this soft material reconceptualization. And so these three texts, quite recently published, all help support that, and I'll just quickly talk a little bit about them. So the Stuff of Bits by Paul Durish is really exciting because it really kind of focuses on expanding our conception of digital media into assemblages of hardware, software, data representation, spatial practices, computer languages, and other related items. And so Durish is really kind of fascinated with how formats and representation constrain, enable, limit, and shape the ways we can kind of engage and use media, digital media specifically. So like an example would be like, think about how different your architecture project would look like if you designed it in Excel rather than AutoCAD. So like the kind of the format of the tool shapes the outcome. The second one, All Data Are Local, by Yanni Lucasas is also pretty interesting, where he calls for new models of very explicitly local practice with data as a way to form close relationships with not only data, but also the conditions in which the data are manifest. So he's really actively trying to kind of connect data to place. He recognizes that data are kind of cultural artifacts affected by numerous factors, including the people that create them, the time and place they were created, the audience which they were created for, and the instruments and machines used to create them and consume them. And he offers a really kind of, I think, a kind of on-point example, citing Boston's Arnold Arboretorium, so like a kind of, for lack of a better term, a kind of museum of trees. And there's this kind of story that he references where in the 1970s, the museum, or the Arboretorium, planted 2,000 hemlock trees And for them, these were kind of untracked filler trees, just to kind of separate one part of the collection from another. And then basically in 1997, so 27 years after, there was a kind of pest infiltration into the collection. And basically, in order to support helping these hemlock trees that were infested, they basically had to be added to the collection. And so all of a sudden, if you look at like the data of this place, it looks like in 1997, their collection like exploded with 2,000 new entries. But if you were to visit the place, the actual place, from one day to the next in 1997, the place hasn't changed at all, right? So it's actually just this kind of historical kind of blip in how the place was organized digitally or from a data perspective that really affected. And then there's this kind of complementary reading that is radically different. And so the last one, Kitchen and Dodge, the code space concept, is that basically, this is probably the oldest one here as a book, but really tries to kind of work to understand how everyday life unfolds in diverse ways through a mutual constitution of software and geospatial practices. And so, for example, they kind of are tongue-in-cheek and say that, like, you know, when the transaction capacity of a grocery store goes down because the internet goes down or whatever, it's actually effectively converted into a warehouse for that time. And so basically the software and the systems allow it to be actualized as a grocery store. And without them, it would be something different. And so those are the kind of three books that I think are kind of like setting the stage for people outside of architecture to want to have these kind of material, socially minded, culturally specific encounters with digital components and software embedded elements. And so the software materials reconceptualization that I spoke of earlier really situates code, data, and algorithms in the architect's domain. And thus, explicitly managing their effects becomes part of the architect's design solution. And so kind of zooming out a little bit, as a discipline, we know that architects have a mature and robust practice of reading the built world from technical, social, and cultural perspectives. We're trained to review projects in terms of impacts on occupants, neighborhoods, environments, and so forth. We acknowledge that we're responsible for creating a built environment capable of enhancing certain values while downplaying or rejecting others. And sometimes, as a profession, we rise to the occasion and we go beyond compliance and baselines and work to enhance targeted values. And I think actually like this, and I use this project a few times in my work, the Pam McConnell Aquatic Center, formerly known as Regent Park Aquatic Center in Toronto by MJMA Architects, is a really, I think, excellent example of how kind of really pushing the boundaries on concepts of accessibility and inclusivity led to kind of an implementation of bold moves, specifically around the ideas of the change rooms and the envelope of the building. And so for those of you who don't know, this building is kind of radical in that the change rooms are throughout the whole facility are universal. And so in fact, on the picture on the right, we're looking into the change room from the pool side. And so that's kind of counterintuitive and pretty much goes against every typology of change room that we think about. But the concept is that everyone uses a large common space to prepare for swimming. And then there's small cubicles inside that space to give you privacy as needed. And so this is kind of like a radical idea around kind of inclusivity and accessibility, because this universality creates a comfortable and welcoming environment for all and works to neutralize issues around gender identity, and also allows for increased levels of safety, especially for younger swimmers. And so that was kind of an example where there's a kind of intent to really challenge a norm and increase as a result kind of a social and cultural issue around accessibility and inclusivity. And then similarly, the project does a lot of work on the envelope. So there's this kind of airy pavilion-like space, and that extends, of course, to the treatment of the envelope. You can see in the picture on the left that there's basically a pretty porous ground level condition with windows running around the entire perimeter. And so this is excellent for the most part, because it works really well to kind of embed this thing as part of the community, as a welcoming space for everyone. The flip side of it is that it kind of created a very present and real barrier for a really important group of the community, namely Muslim women, who actually can't be seen swimming by men. And so strategies in the past might have been carried out as like creating a kind of segregated or smaller swimming school for those people to use, for the women to use. But so resisting that kind of temptation, the MJM chose to kind of support, in fact, what becomes a very dynamic conversion of the building, using a kind of system of motorized blinds to veil basically the hall and the change rooms when there's women-only programming. And so in both cases, like, yeah, architects are good at this, right? We know how to read a space, we know how to innovate, we know how to be thoughtful through the lenses we look at, and there's a lot of opportunity to make great things. And so for me, like at the core is like now that these kind of soft materials are part of the architect's toolkit and the language that they use, I'm advocating that this kind of innovation and spirit should be felt as required and accessible and demanded across all elements of an assembly, which includes, in my kind of emphasis, the soft materials. And so this builds up to starting to think a little bit about how does that happen? And it's, of course, a big project, and it's not obvious. We have to learn how to use the materials, and then we have to learn how to critically engage with them. And so to start that journey, the research that I'm leading has kind of developed a project anatomy framework to help. And so fundamentally, new forms of critical computational literacy are demanded, not just to ensure that soft materials are technically robust, ensuring that they operate safely and reliably once deployed, but we also have to acknowledge that there's spatial material agency and engage with them on social, cultural, political, and ethical terms, just like we would any other material project that we have. So in this regard, the project anatomy framework aims to engage these questions by offering a new lens through which to analyze software embedded design projects. So I'm not going to go into it in too detail because we can talk about it later, but I'll quickly describe the framework. The first part of the framework is designed to examine a project's anatomy, understood as a combination of its participants, actions, and material makeup. It organizes participants into 5 categories and 2 subcategories as shown here. So the 5 categories are citizens, community groups, institutions, non-human species, and environments, and then each of those are either thought of as being situated or remote or active or passive. And so for on the right-hand side, you see the kind of participants identified in the amphibious architecture, which is one of the projects I showed quickly earlier. And for a bit more context, just because we'll be walking through using this as an example, the amphibious architecture project presents this kind of water-based network of sensors and lake beacons designed to support collective kind of interests in the environment by celebrating and promoting data collection by way of an eye-catching dynamic light display that was installed in New York's East and Bronx rivers. So it was the one that, I can go back to it later, but it was like this kind of network of floating beacons in the river. Which you'll notice that there are kind of like in the slide on the left side, non-human actors, including the fish, all the way through a whole bunch of kind of human actors, including the designers, the water becomes an actor, all these things sort of, the emphasis is to really be inclusive of who's considered as being part of the, impacted as a stakeholder in the project. So moving along, of course, these actors do things. And so the kind of framework starts to organize 9 types of actions defined and organized along a get-set spectrum. So the get actions deal with like the lower level interactions. So use cases and scenarios primarily defined by accessing or retrieving project amenities. So like looking at the lights to get some information is an example of that. And set actions see participants assign and manipulate project states. So that's a much more empowered state of participation. And so as you see this diagram unfolding on the right-hand side, we expand the diagram for that project by enumerating available actions and linking them to appropriate participants. So the fish can be sensed. That's pretty much all they can do. But of course, an active situated citizen can kind of interact with a few different details that I didn't go into, but like they can text the fish if they wanted to, which creates a response in the light. And so the kind of the end of the first stage is concluded with this addition of a material makeup, which is the kind of lower arc of this drawing, where we start to, for all these projects that we're studying, really enumerate the material composition and kind of organize it into three categories. So soft materials, data streams, databases, algorithms, and code implementations, things like that. At the other end, there's hard materials, so all the physical materials that we're typically thinking about in projects. And then in the middle, there's something we call SED-ware, or software embedded design ware. And these are physical elements that are directly supporting soft materials and often acting as links between the real and virtual worlds, including items such as sensors, actuators, microcontrollers, and conduits. And so even just this kind of act of enumerating these things that often get kind of black boxed in these kind of architectural implementations of software embedded design is a big step. But then we also start to kind of trace them and connect them and really kind of show their agency in the impact of the project as it relates to the spectrum of actions that are available. There's a second part to it, that is a bit newer still, but it's starting to kind of assess what we find in that first part, and it leverages that information into a reflection on starting to project wide-ranging values and outcomes, both planned and unplanned, that we want to bring into the focus. And so we want to engage these projects in terms of rights and security, participation and experience, equity and access. And we sort of do a kind of analysis on where we think the projects are strong or increasing in their capacity, and where these projects are maybe taking things away from the family of actors. And so I know that's a lot to take in, but this is sort of the takeaway, which is kind of, it doesn't only really allow you as a kind of approach to understanding this kind of world of projects. The framework doesn't allow you to just study one project, but because of the kind of standardized framework-like approach, you're enabled to kind of read across projects. And very quickly through the kind of visualization strategies and the kind of organization, you can really read kind of different degrees of agencies of material entanglements that we like to call them, and the outcomes that the project makes. So there's a kind of power to kind of thinking about and normalizing the analysis in this way. And so zooming this back out a little bit and maybe offering a way to get back into it during the discussion, I really kind of see these sort of software embedded design projects as actively moving from kind of test beds, which is where they have been. And of course, like the impetus of like the 5G and like smart city moves and all that stuff, these things are kind of rapidly pushing out to be real world deployments. And so we need to support engagements that maintain a connection to the complex urban condition in which these projects operate, and not kind of be blinded by their tech focusedness. And I think the kind of materialist account of embedding computational components can really serve as a way to complement the performance-oriented engagements with software embedded design that are often very important and unfortunately, in my opinion, dominate the way we talk about them by exposing, so this approach exposes an alternative, harder to measure perspective centered on social and ethical impacts and outcomes. So that's the kind of intent of the project, is to really just offer a different lens to explore this work in parallel to the ones that are already being kind of celebrated and published in traditional architectural avenues. So that, I think I'll stop there. I hope that's enough food for thought. And again, I want to just thank the team that's been involved in this work in the past. Looking forward to the next steps, and happy to answer questions before our next presenter if there's time for that.
Yes, thank you so much, Maya, for your amazing presentation. If anyone has any questions, please unmute yourself, and if you want, turn on your camera as well, or you can also type into the chat bar on the bottom right of your screen. We'll give a few seconds to see if there's any questions that come up. If not, I think I'll ask one question I have about the presentation you have. And I think it's like sort of a chicken versus the egg kind of question where if there's a way to passively collect all this data to better suit the end user's, let's say, behavior or condition, do you see a danger where these design systems, coupled with advancement technology, could start to influence the way occupants actually behave in the space? And in fact, that would the building start changing because it's so much more adaptly recognizes how we would want the space to perform, start affecting the way we now view architecture or our built environment?
I mean, I'm certainly happy to kind of just talk about that for a few moments, and I'm sure it'll come back later. I mean, I think as architects, we are fundamentally interested in how to support people's experience of space, right? Like we think that through our training and through our abilities, we can offer an experience or an environment that enhances and improves the built world. So certainly, I think if I'm arguing for soft materials as being part of that, then yeah, they too can be used to enhance and improve the built world. But I just kind of I flag, I think very importantly, and part of where my soul is and my heart is in this research is that I recognize that soft materials are often invisible and they're often not really thought of as designed entities. And so I guess at the core is the same kind of questions and the same kind of criticality we would show and use to decide whether this is a good imposition of our abilities to shape the experience of the built world for our buildings' occupants. I want that same level of criticality to be applied to the way we not only conceive of, but then further down the line implement these technologies. Hope that answers your question.
Thank you. Is there any questions that any of the audience members may have?
We'll duke it out later.
Yeah, I think we can move on then, and we'll save it for the panel discussion. Thank you so much, Maya.
Okay. I'm still here. I'm just going to turn my camera off. Wow.
Sounds good. We have Alice Huang next. Let me just pull up my script. So our next speaker is, of course, as I mentioned, Alice. She attained her Master of Architecture degree from the University of Waterloo School of Architecture in 2021. Her thesis, titled Site Finding in a Complex Urban Landscape, adapts regional-scale computational design tools such as geographic information systems and analytic hierarchy process to analyze the city of Toronto. Her thesis describes how different GIS tools, concepts, and dataset types can be combined to perform a site analysis in an urban context. By utilizing data processing and visualization tools such as QGIS and Python, she mapped out the optimal placement of community gardens in Toronto for nonprofits and environmental organizations. So here we have Alice to present, and please take it away.
Hello, can you guys hear me?
Yep.
Okay, sweet. Let's see, screen is probably the best way to go. Okay, I actually won't be talking too much about my thesis. I'll just be talking about components of thesis that I was able to work with. Mostly I'll be focusing on actually how I work with the kind of coding tool of Python in a more data analysis kind of way for architectural site analysis. So,
hi, I was just sorry to interrupt. This is just for recording purposes. Could you minimize the bottom right of your screen? We can see the, yeah. Thank you so much.
Okay,
yeah.
Awesome. So for thesis, I'll be talking about two components of thesis on how I apply Python and how I work with it. One is for creating network kind of visualizations, and second is for me when I was doing a characteristic studies for existing community gardens in Toronto. I had to compare spatial conditions, and then I use Python as a tool for visualization again. The last one is more so of a food for thought. It's more of a course I attend. So these are just things for you to kind of think about if you ever wanted to work with things like this in the future, to see the kind of programs and the kind of tools you can use for yourself. And the last one was like a urban analysis tool using like recordings on existing locations, and then you can use machine learning such as image recognition to map conditions into a plan. So I'll talk about that later. So starting with kind of network thinking and application, you can kind of think of the diagram I was kind of thinking of was generating is this relationship diagram between components. When we break things down, we always break it down hierarchical in some ways for the most of the time. But we also understand that things have a certain relationship to other elements. So in this case, I'm saying, say, if I isolate road as a condition, its composition and its constitution is related to other things and such as transit, public space, demographic, and density, and they all kind of affect each other. So the way a network kind of diagram will work in this case is that you can use like adjacency matrix, which is what I'm showing here, to kind of generate relationship mathematically. The way a kind of very simple graph, a network graph, works is on the right, which is like there's a bunch of nodes, and then the kind of relationship between them are created as edges. So so these nodes will be like the geography, topography, things like that, and then their relationship would be the edge. So in this case, I was kind of asking what's the relationship between climate and hydrology, and how strong is the relationship? What is its condition? So you can see that in the green portion, those items have a stronger correlation to each other, and then they may slowly fade out. So with this as a kind of table, I was able to feed this into a program called Jupyter Notebook. So this is something that data analysts use a lot more. In that you can use this to kind of create code blocks and execute these code blocks and generate within each code block you can generate you can ask yourself like what are the information if you need to check information, or in this case I was able to use it to generate this diagram in SVG, which is like a vector diagram, and then I was able to clean this up in Illustrator to create this kind of diagram to kind of show the kind of pull and the complexity of relationship between one another. So in this case, things that are not as important are off on the side, on the edges, and things that are more important and more to the network itself, the system are in the center. So population density, road, and transit, they have a higher vector value, I believe, that I was working with. So there's very specific mathematical terms that people were using. I also use adjacency matrix for the suitability analysis within my thesis. So you can kind of think of it as I need to overlay all of these factors together into one map. Which one is important? How do I know that? And so I use the process called analytical hierarchy process, which is asking a relative importance value. Is A more important than Y? And by how much? Is it a little bit important, a lot more important? And then the inverse of it is the kind of response to it. So using this, I was able to determine criteria weightings for these elements, and then kind of create this combined suitability raster map. The other thing I was doing with Python in my thesis was the characteristic studies. So you can kind of think of it as I had information about 200. I had the GIS coordinates of 270 community gardens in Toronto. I wanted to know its distance to programs that I thought of as important near this community garden. So schools, parks, hospitals, community centers, community housing. How close are they? How far are they? Transit and then roads as well. So the way I did it is I evaluated it in QGIS, using a tool called nearest neighbor analysis. So it measures the direct distance from that point to the nearest point, and then it will collect it as a table of data. And then I also repeated the process for 270 random points to kind of create a kind of baseline condition. So then I have something to compare to. But that was so the data was collected and processed in QGIS. And then I will move into Jupyter Notebook to process the data and then export the visualizations. So this was kind of some of the visualizations I was able to export and compare. So you can see that in the park, so the way to read this, so this is called a Boxen plot. There's it's kind of like a box distribution. So these are the data points for the 270 community gardens, and then it's plotting the distance to proximity to parks in that case. So the way to read it is the closer the number, the kind of plot is to 0, the smaller the distance the community gardens are to parks. So you can see that for like parks, majority of the parks are less than 500 meter, are within 500 meter radius from a community garden, and the average distance to a community garden is like 62 meters. So with this, I was able to process a lot of information. I also did a similar study for census, looking at census tracts. So first creating a buffer region in QGIS to isolate the census, and then kind of compare the isolated census tract with the kind of Toronto average that I was able to determine. So on the right, you can see a few of the highlights. The way I kind of work with this was kind of calculating the difference. Like, what is the difference in these kind of conditions? So the ones that are darker in color, such as apartments or ownership, you can see that there's a stronger correlation, that there's a lot less owners, people who own houses within census that are close to community gardens, and there's 17.3% more people renting when they're living in census close to a community garden. So the one that was like I was talking about for my thesis study, which I found kind of interesting, was dwelling before 1960. So this means that within this census, the buildings are built before 1960s. And this combined with the fact that there's a lot of apartments kind of means, is kind of something that I was able to speculate about. There's no certainty on any of these. So I was only thinking of these as relationships. There's no certainty on cause and effect at all. So potentially, maybe there's a relationship between community gardens and post-war apartments, which are built with like this tower in the park typology. So the last one is going to be a food for thought. So I took a course on from IAAC last year on AI urbanism, which is focusing on urban analytics with computer vision. So majority of this was done in Python with OpenCV, which is like an image recognition program. And then YOLO and MassRCNN, you can think of it as a pre-trained data sets that's available for you to use. And it turns out machine learning was not as difficult as I thought, but it's also not as easy as I thought either. But especially when you have a pre-trained data set, a lot of the tools were there for you. So this with YOLO, the script I was using was already pre-trained for 81 different objects. So it was able to recognize cars, people, not houses, but other things that were moving as well. So the way you can kind of work with something like this is to take what's it called when you're surveying, like a video footage, a video footage of something that is constantly moving, like cars moving or for tracking. I forgot what those are called. Anyway, so a footage, and then you can use pre-trained computer vision and work with this kind of code-driven image manipulation. a perspective to kind of map it. This doesn't make much sense, but the right is the code, is some of the code. But the way it kind of works is first you recognize the object. So with the pre-trained model, so this was for Nuit launch in 2019. So this was doing the installation or the setup. I think I'm on the right on this image too. So the script was able to identify each of the people and its location, and then it was able to map the location as coordinates. The way it did that is, first I had to locate 4 points and on this image, so this perspective doesn't change. So the camera perspective doesn't change. That's one of the key. And then I have to map these points on the image, and then in real life, in GIS, I had to locate where these points are in real life coordinates as latitude and longitude. So that will feed into the system to tell it, so to manipulate the image, all of the image in a certain way, so that these points of where the people are can be mapped onto a plan. So yeah, the points. So now we can look at the points of where people are onto a kind of plan perspective, like this. So this was the kind of running of the video. So this was like the time lapse of the installation. You can see that I was able to recognize some of the cars as well. But there's also a lot of problem with this approach, doing it in plan. Like, it's better to do it in a higher perspective, because this is what ended up happening. Because the camera was located on the left over here, majority of the mapping was only available for this portion. So it almost seems like for our installation, this is where majority of the people gathered, which is not. Like, if I had it on like a lamp over here, I might have a better information. I might be able to get better information about where people were doing the installation. So this is a still. I was also able to get like a real-time kind of loading of this kind of information as well. So this was kind of just a flattened version with all the time collapsed together. But you can kind of imagine how this can also apply to as sequential in doing a project like this. And yeah, that's it. Thank you. So these were some of the things how I apply Python and work with. I had a chance to work with Python in a certain way for thesis and for some of the things I was interested in. Any
Thank you so much, Alice. Any questions in the chat? If you are shy and you don't want to raise your mic, please do type it into the chat bar. Sarah. I think that, oh, yep, Simon.
Hi, can you guys hear me?
Yep.
Yeah, thanks for your presentation, also to Maya, but the question that I have for you, Alice, is what prompted you to learn Python in the first place?
I was working with a lot of site data and working with data in general and GIS, and quickly Excel was not enough for me. I had a lot of information I need to process and filter. So I decided to move into the Python world, and it with like a data science kind of approach rather than the kind of coding in the backend kind of approach. It was easier than I thought. It was a lot more of a streamlined process. Like, it's very visual, and you can pretty much get things in there and done, and get stuff out of it pretty quickly. So I enjoyed the workflow, so I decided to continue work with it. Yeah, and I also took a course in M1 and 2 called computational social science. So that was really fun.
Nice, thanks. I might have another question unless somebody else has a question first.
No, I think you're good. Please shoot away.
All right. Yeah, my other question was about your adjacency matrix and some of the other tools that you used. I was wondering how you came up with the values in those charts. Were those kind of based on your own reasoning, or were they
based on my own reasoning for majority of them? But the way an AHP is supposed to work is you would be asking these questions. You would be formulating a set of questions to researchers and then asking them to answer these questions. And that would generate the kind of adjacency matrix for AHP so that they can determine the weighting based on their kind of thinking.
Cool, thanks.
Oh, we have a question in the chat from, okay, there's two questions. I will read the chat one first, from Thomas Weinberger. Do you believe that Python and or a data science applied mathematics methodology will eventually become a mainstream tool within future architect software arsenals?
Let me think about this for a second. Some of it, maybe not all of it. Right now, it's still not the easiest thing for me to work with. Maybe part of it. I'm not sure. It's something, it's like that we will need to understand logics behind how things work in terms of how softwares work. But whether or not we fully need to know things like Python, I'm not too sure, to be honest. It's a great tool, but there is a learning curve to a certain extent. Yeah.
I think I'll just expand on that question. What would be the benefits for architects and designers to, I guess, adapt these kind of technologies within, I guess, let's say a design process?
These are better for research tools, to be honest. Like all the things I've been showing, they're more for research rather than for design. So maybe more so for research and analysis, set analysis more so. On the design perspective, we still have Grasshopper and things like that to kind of embed logic into how we work.
Awesome. Thank you. Are there any other questions that the audience may have? If not, we'll move forward to our next presenter. I think that's it. Thank you so much, Alice, for your wonderful. Yep. Thank you, Alice. Up next is Jonathan Enns. Let me just do my introduction with Jonathan. Where is it? Give me 1 second, sorry. So Jonathan is an assistant professor at the University of Waterloo teaching courses in architecture and architectural engineering program. He runs the Humanities Lab at the School of Architecture, a research group focused on exploring the paradigms of human-centric design. A graduate of the University of Waterloo School of Architecture undergraduate program and Princeton University's MArch program, Enns has received many awards, including an Archie Prix International Award for his design work on computational design systems in 2011, and the Hollison International Award for Sustainable Construction for his research into the carbon benefits of massive timber construction in 2014. So with that, Jonathan, please take it away.
Hi guys, can you hear me?
Yep.
Good. Let me just share here. Let me switch the screens here. Okay. Chris, can you see the title slide there?
Yep, it looks great.
All right. Well, thank you, everybody, and thanks to Formlab for setting this up. I think it's really nice to have the chance to have these types of discussions, and it's nice to see the student faces and some old faces come back. So I hope you guys are all doing well. I'm kind of gonna give I'm gonna go 30 seconds a slide here because I know you guys want to see some work. So I'm gonna go a little quicker, but that the first two slides, I'm gonna try to make a bit of an argument here that we be critical of technology. And I think that's within the realm of technologists, people that I'm assuming are here to talk and think about technology. I think that my position on this stuff is that we also need to develop robust rationale for why we'd apply technology. So I want to talk a bit about that. My work is about how we shape practice. I'm really interested in practice. I kind of have three things that I do, some at the school, some not at the school. The image on the left is Humanics, and that's generating work that some of you guys have been engaged with that really is research for design. So we're trying to generate kind of findings, principles that can aid designers in practice. EDA, which is END's design office, is me. I'm really doing research through design. So I'm doing projects myself, mostly myself, and then some of those are turning into research, and I'm looking at insights from producing work. And Northern Assembly is what I've been up to for the past year. And so it's really a question of how to engage a community in mobilizing knowledge through the building of a network of other people. And all of these kind of have technologies as a part of them. But I'm really interested in form and technology, mostly for what it can do and not for what it looks like. And I think, you know, with technology, I'm almost as interested in when we shouldn't use technology as when we should use it. And so I'm going to try to lay out just some ways of thinking that I use to decide how to be strategic. So I'm just starting with a Robin Evans quote. Architects do not make buildings, they make drawings of buildings. And I think as a practitioner, it's important to remember that the object of our labor, documents that lead to buildings, they're the instruction manuals. And they're highly influenced and shaped by the tools that we use. Drawing on paper influences the documents. Using projective geometry influences the documents. And using Python or scripting influences the documents. And I actually think as people that really make documents for buildings, we need to be critical about how those technologies shape. So the tools we use, geometry, software, and representation, are not neutral. They actually influence the thing. And that's where I see room to be critical. The things we make, we know we make buildings. In the end, it produces a building. And we know those buildings support larger systems. You could call these the externalities. So the second order of impacts. You think you're designing a building to influence, how far a user has to walk when they go to the bathroom, but actually there's externalities which are the larger impacts of putting a building in the ground. And often these externalities support systems that are unfair to people. Maybe it's capitalism, maybe it's environmental degradation. And I think that I hope that we're entering a phase where we are starting to question the externalities of design as much as the initial impacts. And I think this is a question that you can also ask about the geometry, the form, the tools you use to produce buildings. And one particular area that may be of interest to this group is kind of the externalities that come out of complexity. So here you have migrant workers in Qatar putting together a complex building under horrible kind of social pressures. There's lots of things you can look up around the Zaha Hadid buildings or the kind of labor disputes for these migrant workers, if you're interested in this. And I think what's interesting or what's important is to question how our reasons for form produce these social conditions and how we might question those and find better options. And I think, if there's one thing that we have to be critical of, it's complexity for complexity's sake. I think this is something that we see a lot of, and I don't want to seem like I'm ultimately an optimist, but I think there's room to also question technology, as I've said. What externalities does this knowledge, does this obsession with, complexity and fabrication imply when we get to buildings? And I took out a bunch of slides, but I think this is what you see when you search for parametric architecture. But I think this should seem familiar to everybody, that this seems like what form is about today. And I kind of want to make a case for actually a more complex form that doesn't look complex. So this all looks complex, but as we know, it's relatively easy to generate digitally, and it's relatively hard to make physically. So I kind of want to talk about those forces. I will also note that I've been in this business. I'm complicit in the formal complexity world. I worked at Front. I was part of the formal rationalizing industrial complex. So there's this whole world of companies that have generated to figure out how to build architects' crazy forms in reality. And I worked for one of those, and that's a great place to learn maybe what the pros and cons are. And I guess what I come out wondering is, why aren't we searching more for the simplest desirable solutions? We're often looking for the most complex solutions or the coolest or the most novel, but who's building the simplest desirable solutions? And I think the other questions to ask is, this is an important framework for me, is to always think about desirability, feasibility. And if there's one thing that you could apply to your own work, it's I've got an idea. Where does it sit in terms of desirability and feasibility? But some important things to think too is desirability for whom? Is it desirability for other architects to look at and comment on? Or is it desirability for your clients? Or is it desirability for the end users? That's a really important question. And feasibility for whom? Is it feasibility in terms of the budget, or is it feasibility in terms of construction or fabrication? And so I'm really interested in desirability for the end users and feasibility for the constructors, and how to develop tectonics. So an actual poetic that comes out of these two forces. And so I think it's been a helpful framework for me. One term I want to introduce to you guys is actually two here. I'm making up this term appropriate geometry, but I'm riffing on a term called appropriate technology, which I would urge you to all look into as a kind of philosophy in a field of thinking that really does think about simplest possible desirable technologies. So, in the search for these simpler, better forms, what does geometry and computing have to do with it? First, let me just define appropriate technology. It's a movement and its manifestations encompassing technological choice, an application that is small scale, affordable by locals, decentralized, labor intensive, energy efficient, environmentally sound, and locally autonomous. It was originally articulated as intermediate technology in this book, Small is Beautiful, by Fritz Schumacher. It's a bit old school, so it's like it's like 60s, 70s. But both Schumacher and modern day proponents of appropriate technology also emphasize technology is people-centered. So that's the kind of overlap with my own interest in human-centered design, but it all kind of dribbles down to this term, open source appropriate technology, so OSAT. Small scale, affordable by locals, decentralized, labor intensive, energy efficient, environmentally sound, locally autonomous. So this is the work that I'm trying to produce, and the questions I guess for this audience are, how do our tools support this? I've mentioned this. I mean, we're looking for simple and desirable. I will also say that this is deep for me. You're looking at, if you can see me, you're looking at 3 generations of Enzas here. There's my dad standing and my Opa on the back tractor. And my Oma on the left emigrated from Russia, and this was her village in Russia. And we were Russian Mennonites. And while we're not old orders, I think there's hidden, in plain sight around us, there's kind of success stories of communities that have been strategic about their application of technology. And in many of these communities, the question was, how does a technology impact social structures? And, do we actually decide to use a lower technology because it may be more beneficial socially? Or do we ultimately always kind of opt for high technology? And I think that this is an important question, just not for me only, but I think today, for all of us, if you've seen The Social Network on Netflix, or you've seen how technologies are starting to kind of influence social networks, it's really important to think about what is our position on this. So I would say generally, if there's an enemy, it's to not have form first, and I think that's where there's a critique for some of these complexity projects. I would say that appropriate geometries employ computing paradigms that are problem and context led. So they start with a problem, they start with a context, and that is largely a human thing. It's not necessarily a technology. So their complexity lies in the ability to manage, control, and arrange found geometries. And anyone that's kind of tried to engage with this problem will know that that's actually very hard, and it's very complex. So I think that we should be really impressed with projects that actually manage to deal with found geometry. So I want to run quickly in the remaining kind of 7 minutes through a few paradigms. I maybe will introduce the beginning few slides and then click through them so I can get you through kind of 3 paradigms that I see as a bird's eye view of appropriate geometry. So kind of like computing paradigms and tool. I see geometry as a tool. Tools that could support OSAT work. So the first is where I started. This was a thesis. This is my thesis, grad school thesis, where I was critical. I started critical, and I said, why are we obsessed with making non-standard? If you guys research the non-standard movement, there was this movement looking at continuous differentiation and non-standard production, and how we could use digital tools to make complex objects. So forms that were complex and gooey and different every time without the cost of that, because we can use CNC machines, for instance. But my question was kind of, why are we doing this? Why are we moving these beautiful structures like non-standard trees into standardized materials? What do you guys make those non-standard things out of? You make them out of standardized, MDF. You make them out of standardized. You've kind of, we're building these very illogical material flows. So standardized objects into non-standard shapes. How could we go straight from non-standard stuff to non-standard forms without that kind of inefficient process chain between it? So this is an old way of building. This is a low technology way where the Vikings would head out into the forest, find the tree that looked most like the bough they were looking for, and use it. So my project was to understand found geometry. I headed out into the field and scanned 10 trees, came up with 83 joints. This used photogrammetry at the time, but I'll show you some projects that kind of spun off from this. So this was our joint catalog. This is what this is like yes, it's digital on the right, but again, didn't really care, but this was a tool to get us there. This was a video that's not working, but built a rig in Grasshopper. This was 2008. So things have gotten. I'm a little. I think I'm saying I'm a little rusty, but in 2008, I was getting the angles and the vectors from all of the found nodes, and then using some goals to build structures from those nodes and applying structural goals to these. And in the end, it produced a building whose structure or frame was generated from the found geometries on the site. It was a formal project, yes. And I think that what stuck with me from 2008 is the philosophy more than the kind of formal focus, but the philosophy on using found geometry. And the challenge in this project was really like manipulating and controlling those geometries. Many parts of the project were cited intentionally or not by the AA Woodchip Barn project. They actually have a few of my slides in their presentation project, but these guys actually funded a project in 2015 to do a very similar thing where they scanned trees, manipulated them with CNC machines, and were again trying to use this natural complex material to actually get things they wanted from it. I think this was an old project, and Chris mentioned maybe wanting to see it. I want to show you the guts of the project a little bit. This was a project where rather than using found material, I used something very accessible to everyone, which was just sun angles. And again, it wasn't form first. The question for me was, how could the form of an object emerge from existing data in the field? So I'll kind of just go ahead and we can come back to it later. But this was a clock, and the complexity of the clock was produced by these Swiss cheese holes that were intersecting and really produced by sun angles. And my goal was actually to be as neutral as possible, to not try to make anything crazy at all. It was to let the channels do their thing. And so this thing kind of tells time as the sun swings through the sky. It projects the time of day on the ground. I think so if that paradigm was kind of found form, found objects, bottom up, I think another paradigm is to think of human-led, so to think of the form as emerging from people. And I think you have some peers that have all kind of contributed to this. I think there's self-build. There's also self-design. I think IKEA does it really well. And you think computing paradigms, I think this is a really interesting area to be, is to challenge IKEA at the scale of architecture to let people use platforms to assemble their own architecture. Shout out to a few thesis students out there. I've been building these systems for years. This was work with Dan Hambleton from Mesh Consulting on a user configured housing block that also had a tangible user interface. So a little model that they could, this was the digital kind of version where people could assemble, planners actually could assemble the location of towers in a block. And there was like a fusion between the thought of the structural rationale of the design and the tool. You needed the structural rationale that this cross-lam in this enabled, these kind of overhangs, for the tool to work, and you needed the tool to work to get the benefit out of all the extra structure we put into the building. So there's user generation, ARC 570, which some of you guys were in, was the same thought of how to build convivial tools or build tools that end users could generate themselves, as much for research in this case as literal design. But you could make the jump to figure out how this could actually be a literal design configurator. But I've done this in practice. This was work at Continuum Innovation, essentially the same idea. This by the way is their work, but a project that I was lead on down in Boston. Looking at the same thing, how we can engage end users more closely in design. And that's what I'm doing up here, is to think, how do I lower the technology bar in remote communities? So I'm up in the Arctic, really thinking about how to build systems. And I'm going right down to basics. My system is Facebook and engaging the community and publishing instruction manuals like a Ken Isaacs from the 70s. Check them out. And trying to figure out how geometry can be more as simple as possible. I think I'm going to skip through a few more just to show you the kind of end idea here. I'll say a few things in terms of paradigms. I think we should make our digital world behave more like the physical world, not the other way around. So I don't think we should be figuring out how to make our physical world emerge from our digital fantasies. I think we should be embedding the physics of the physical world into our technology. Karam, our esteemed colleague and one of my thesis students, was an example of this with his thesis on embedding wayfinding and perception into Unity-based wayfinding. Amazing work. And I think this is the theme: embed more knowledge into our digital models. And I think the kind of end fantasy on the Northern Assembly stuff, so that's the stuff I'm doing up here, is actually to start getting into kinematics. So on the right, we have CATIA, which is something I used at Front, where, in industry, you have a lot of simulation that happens for design for assembly. If you're making an airplane, you need to figure out how to put it together. And actually, there's very robust simulation that happens in that industry. How do we use those tools on simulation and on real world constraints and apply them to understand what novices and people with very little skill, what capacity they have? And so on the left, we're actually seeing a publication that diagrams out Walter Siegel's self-build system, which has been used for the last 30 years, very successful, and actually shows the physics and the loads that are caused at the tip, the shoulder, and the base of a person assembling these frames. And my kind of fantasy is to envision merging these two worlds of the kind of old analog 70s instructions on the left, which really figures out what the stages are, with our new tools that are interested in really kind of simulating the details of assembly and the impacts on the assembler, and really asking how much superpower can we give to a non-expert? How well can we understand that? So I think that's it for me. If anything, I think appropriate geometries employ computing paradigms that are problem and context led. The complexity lies in the ability to manage, control, and arrange found geometries. And so we're going problem versus product led. So thanks. That's what I've been looking at, and this is what I've been excited to work on with a bunch of you guys. So that's it. Thank you.
Thank you so much for your wonderful presentation, Jonathan. I think we'll open up to any of the audience members if they have questions. Please unmute yourself and speak out. Simon, I think, is your hand still up from last question, or do you have a question for Jonathan?
I didn't know, but thanks, Jonathan. Hi, it's good to see you.
It's okay. It happens to the best of us.
Yeah, I don't know if I actually had it up, but it was really interesting to I don't think I've ever gotten a full view of what the scope of your work like this, and where do you sit with I guess if I have a question, it would be where do you sit today with computational design tools like Grasshopper or I guess algorithmic design tools? Like how does it, I know you talked about like Facebook, which I think is a cool way to address what you're after, but do you still engage with stuff like Grasshopper or similar tools like that?
Yeah, I don't know how to. I was going to say I'm embarrassed to say what, but I'm not. Yeah, I do. I pulled out Grasshopper the other day. So in those simulations, it's called the. I don't know if you guys have seen the Sand Beast. It's this project by, I think he's a Danish crazy designer guy that makes these structures that walk on the beaches. Anyway, the kinematic study I did was the actual inventor that made that leg mechanism, and I was trying to make that to learn kinematics in Grasshopper. So that was all made in Grasshopper, with physics to learn kinematics, the basics. And I've been doing that. I call them, I kind of do it for fun. which is embarrassing, but maybe it's not. So I think Grasshopper is amazing, but I think it's, am I going to be doing that in 20 years? I mean, I think this is a graduate's reality, is that when you guys graduate, you're going to be the best at the current software of anyone. But as you work your way up in a firm or maybe in academia, you know, you're no longer the point person, right, for the latest and greatest. And I think that's a really interesting. So that's how I think of that question. And so I use these things when I have the knowledge to do it, but there's kind of a barrier if it's beyond my depth. I have to ask Alex Gontars. But I think that there's I think Grasshopper is really great. I think that Rhino is really great. I've learned pretty much every software from CATIA to Revit in practice, and I still come back to Rhino. I know people will say use this or use that. I still come back to Rhino and Grasshopper as something that just is easy. It's like drawing. You know, you'll find you'll always come back to sketching. So, I mean, I love it. So I think it's kind of like the starter software to so many other things. But once you find you need something, you may jump out. Sorry if I didn't answer that squarely.
No, it's cool. Thanks.
Is there any other questions that the audience may have? If not, I think I have one. And I think it's really, I'll say this is kind of embarrassing for me because since you were my thesis supervisor, I think this is the first time I actually get to know and see the work you do, and it's really amazing for me to see the breadth and the time that has taken you to amass this knowledge, which is really exciting to see. But I think there's the first paradigm you mentioned, environmental-led geometry. For me, it's almost kind of like antithetical to what I guess I've been trained in terms of using standardized lumber dimensions for wood design, or even the notion to use engineered lumber because it's we don't have large trees anymore and to be more efficient with the materials. So I think the question is then, if you're saying we should be using environmental-led geometry, how does that really work in society where we're moving more towards automation and engineering building materials as a way to combat I guess the issues of pollution from the building industry?
Yeah. Well, I'll make a clarification. I think you have to define what your environment is. And I think if there's an interesting question, the question might be, how do you remove wasted intelligence from the system? So in my case, I was interested in moving from trees. You tend to throw out the joints. So how do we use those joints and use the information in those joints without throwing them out? But I think in the case, like up here, for instance, the only material, there's not a lot of raw material in terms of certain types of structures. If you're looking to build a building, you only have so many source materials. And so that's what I'm wondering. I think actually my environmental materials are nominal building lumber. And so my question is, how do you build something with the least offcuts? How do you build something with the most structure for the least amount of material? I think that's an environmental question. So the environment up here is different than the environment is in New Jersey. So I don't think it's necessarily about one thing or the other. It's kind of about your definitions and how you might optimize for time, waste, knowledge, etc.
Mm-hmm. That's interesting. So it's sort of how, you're saying that it's not so much like a natural building language where we're trying to be organic, but rather being cognizant about the materials we use and the best way to make the greatest efficiency out of it. I see. I
mean, I'll just give you an example, and I know we'll talk about this, but like I'm building this little shelter, and I will, instead of thinking, oh, the roof, to support the best snow load, the roof should be of this angle. My roof angle is produced by an 8-foot plywood piece tipping this way and a 4-foot plywood piece tipping that way, meeting at this odd join because it requires no offcuts. So the logic is to maximize material. And I see that as an environmental appropriate technology because we're using the existing materials, not forcing some new geometry down that needs to be wasteful or et cetera, et cetera. If that makes sense.
No, that's very clear. Thank you. We still have some time left before the next presenter is going up. Does anyone else has any questions or want to join on into this, I guess, this train of thought that we've now established? I guess the audience is shy today.
Can I ask a question?
Yes, of course.
Hi, thank you for the presentations. Very interesting perspective. I didn't really expect the small is beautiful, like the theme from that book, to be related to this. Like I wasn't really expecting that today, and that was refreshing. I was wondering if you had more examples of getting into the difficulty of using like found geometry. I think that's really difficult in like the work that we do, and the barrier maybe between fabricators and architects is like the drawers and the the makers.
Yeah, I think it's such a huge. We should have a session on. Yeah, I think. How many ways could we answer this? So anyway, I think that there's all kinds of things to talk about there, but I think physics is a really interesting area to get into. I think like kinematics and physics-based simulations. I mean, I will just say, like, I don't know. I mean, I can talk a bit about CATIA. They're called mannequins. So the mannequins are the people in CATIA, and you can teach them to do things and figure out what the limits of movement are. And I think that's a really interesting frontier. I think that, Karem was actually getting into, I mean, this isn't so much fabrication related, but kind of embedding wayfinding agents with some kind of behavioral preference. So like he had agents that would enter an airport and really have to eat a hamburger or really have to go pee. Like this is a new frontier, I feel, for us, because I think it's really getting away from Neufert's, which is great, but it's moving into, an exception-based design. And I think that's really exciting. But in terms of fabrication, I don't know, there's also old school stuff. I mean, it doesn't always have, I mean, I think, yeah, I don't know what to say. I think the most helpful thing, I was going to say, the best teaching lesson I had was actually building a canoe in my last year of undergrad with you guys at Waterloo. I built a skin-on-frame canoe where I modeled everything in Rhino and then steam bent stuff. And I feel like the best way we can smooth the language and the translation between architects and builders is to go build the knowledge. And so, I mean, sometimes that could be a CATIA software model, but in a way, I kind of think there's still old school stuff too. So, I mean, keep your hands dirty, I guess.
Thank you.
Awesome. Thank you so much, Jonathan, and thank you for everyone who has asked the question. I think we'll move on to our next presenter. Up next is Alice Gontars, who obtained his MArch degree from the University of Waterloo School of Architecture in 2020. His thesis, titled The Fabrication Commons, investigates how modern fabrication systems can be designed to empower the average person to become a maker, rather than just a passive consumer. The first section examines maker ecosystem and how strong local maker communities can be a catalyst for a cultural shift towards creating. Furthermore, Gontars explores a series of prototypes designed to minimize the barriers between users and their chosen design tools, whether they be digital or physical. So with that, Alex, please take it away.
Thank you very much. Let me, can you see that right?
Yep.
Okay, great. Yeah, great introduction. So very much in keeping in theme with a portion of Jonathan's presentation of engaging the end user in design. So I'll try to breeze through the background a little bit and get to the more fun stuff. So essentially, the digital fabrication tools and networking technology becoming increasingly attainable and versatile, there's an opportunity for more people to become makers instead of just being consumers. So I'm asking, how can we take advantage of this and foster larger local and global communities of makers? To engage a broader audience with digital fabrication, I propose a user-centric ecosystem that attempts to link all the individual elements of the workflow. And then my research involves designing a series of prototypes that would lower the barriers for inexperienced users and allows them to create something unique. And with more engaging, accessible methods of fabrication, people can benefit from the advantages of creating something themselves and form communities that are more empowered and meaningfully connected. Making for yourself or for people local to you is an important part of the human experience. However, small-scale making has lost its necessity and much of its importance today. There are still many of the personal and interpersonal benefits to making that we can take advantage of. So I'll give a few examples where empowering people to create with digital fabrication tools has a positive impact on personal and community. So for example, the IKEA This Ables projects are a series of hacks that will make their furniture more accessible for people with disabilities. Mass producing these would not be feasible for adapting to every user's needs. And Studio Bark shared their designs with the protest group Extinction Rebellion, which is a modular box that can be fabricated with a CNC machine and during a protest can be assembled to occupy a space. Another great example of empowering a group in a way that would be difficult to do otherwise. For some larger contexts, it's important to understand the industrial revolutions. It's typically categorized in terms of 4 different ones, but the first 3 are sort of improvements on the idea of mass production and vertically integrating systems. The important disruption in Industry 4.0 is not only mass customization using digital fabrication tools, but an unprecedented exchange of information. So both of these qualities lend itself to the possibility of successfully decentralizing fabrication. The impact of economy of scale is becoming smaller and smaller in this Industry 4.0. So in terms of economy and culture, having a collaborative model rather than a capitalist model for fabrication is simply more democratic and empowering. Distributing and manufacturing also distributes power. By introducing new people to digital fabrication, we're also introducing them to these collaborative values. And of course, you've seen makerspaces. They exemplify much of these values, but they usually focus on the education aspect and aren't seen as a resource for anyone in the community to use. So there are many impressive projects that focus on either human-machine interaction or the complexity of the final product, but rarely is both combined. So I want to use engaging interactions to excite new users to make something unique to themselves. So I'll slow down on this quote because I think it really frames the problem and the context really nicely. This Adam Greenfield's book, Radical Technologies. And he says, the challenge isn't at all to propose the deployment of new fabrication technologies, but to deploy them in modes, configurations, and assemblages that might effectively resist capture by existing logics of accumulation and exploitation, and bind them into processes that are generative of a lasting and significant shared value. Those interested in seeing digital fabrication used as a part of a project or radical transformation will need to invest a great deal of effort into ensuring that the way in which one would go about using it is actively invitational and not merely demystified and formally accessible. So I made a simple framework that would lead my prototypes of the basic elements that I think go into would go into forming this ecosystem. So I'll go through them. The user's at the center, of course. The space, making, storing, collaborating. The materials, the raw matter, parts, components, assemblies, so on. The physical tools, this can be pretty broad. The device that carries out a particular function like modifying the material. Design tools, used to plan the qualities, function, and assembly process of a finished product, usually digital, but can be analog. Systems, the groups of items which are organized in a way that helps the user reach their goal. and the information skills and understanding of the subject that's transferred, through books, devices, or digitally. And then the interface, which I see as sort of a layer that connects all these together. Essentially, each prototype I made tries to link 2 or more of these elements, and it's the interface that does this. So yeah, the question is, how can we better connect the user to these elements? By creating engaging, straightforward interface tools. So prototype 1, how can we engage multiple people into the digital design process? So my first prototype, collaborative creation, aims to do this using a reactive tactile projection at full scale onto the working material. Does this play? Yeah. So the outline of this design, the outline of the design is projected along with control points that react to nearby users' fingers and are activated once contact with material is made. So this is done using script, projector, and hand tracker. So looking into the future, next step for this prototype would be actually incorporated into digital fabrication tools such as a CNC machine, and adding some restrictions to the design based on the limitations of the tool. And when done away from mouse and screen, collaborating and exchanging ideas is much easier and more democratic. Prototype 2. How can we involve people in the creation of their own raw materials? So next experiment I did was creating raw material from the waste plastic from 3D printing, inspired by the Precious Plastics project. The aim is to allow people to be involved in a part of the fabrication process that's usually inaccessible and taken for granted. So I took my own waste products, got more from the local Cambridge makerspace, which otherwise would have been sent to the landfill, shredded them, mixed the desired amounts, heated, and pressed it and let it cool. So the final raw materials are now ready to be carved, laser cut, heated again, and bent into a new useful product. Through these experimentations, I saw that different colors, grains of shredding, heat, time, pressure are all factors that affect the quality of the final material. So again, the future version would be fine-tuning the process of changing all the variables to make output reliable and consistent. So hopefully this prototype adds a new layer of customizability, gives the users a better appreciation of material life cycles. Third prototype, can an open source expandable kit of hardware make people excited to create and share? So the Open Construction Kit is a reusable set of 3D printed hardware that's designed to attach to scrap material with minimal tooling. All that's required to install this is a drill with a hole cutter. Even the tool that tightens the screws can also be printed. I use the system of parts to modify my workspace to suit my needs. And any user could do the same for their own, and they would all look completely different. You can see a scrap piece of plywood with a weird shape is an offcut from a separate installation. So of course, there's no way to anticipate every user's needs. So they're encouraged to develop and share their own designs and modifications. Not only is this a straightforward way to engage new users into making something larger, but also encourages making social connections. Prototype 4, how can we make people gain a better understanding of what impact different materials have on a project? So the Smart Material Library is a device and collection of samples that can not only give relevant information about the materials, but show the information in relation to the user's particular project. So when the user chooses the physical sample of the material and places it in the device, it will apply the material properties to their project, renders it live, and calculates the metrics such as its weight, price, and carbon footprint. In terms of hardware, it uses a symbol tag reading system. And it was difficult to find much of the material data in one place online, so I had to compile much of it into a spreadsheet for the program to read. The future version of this would work with assemblies of multiple materials and have information about where to find them and how to tool and assemble them. Hopefully this can be an informative tool, simplify the making process, and encourage even experienced users to experiment with new materials and new strategies. Prototype 5. How can a user create and fabricate something unique with no experience in digital modeling or fabrication tools? So the Tactile Designer is an interface tool that does exactly this. Users can choose from a wide variety of pieces, add them in any way they wish, and send it to a 3D printer with the press of a button. So the pieces are at the exact scale that they will be when they're printed, and display the final product on a screen as the user builds. So when the green button is pressed, the program converts the model into code that's readable by the printer and queues it up to print. So, yeah. And that's a time lapse. And there's the piece. So the box uses vision-based markers that convey the ID and location. The challenge here was to update the G-code and send it to a local print server with instructions to start it instantly. The prototype shows the users the entire design fabrication workflow in a clear, unintimidating way. A natural extension would be to incorporate augmented reality for the interaction and support multiple materials, which are then sent to their respective production tools. Okay, last one, prototype 6. How can a user work with a robot as a coworker to produce something with both robotic and human traits? So the primary focus of this prototype was the interaction between the user and the UR robot, and secondly was the product, clay in this test, which is being modified by both the user and the robot. So first the user molds a piece of clay, and its shape is registered by a webcam with a simple 2D vision system. The robot prompts the user to choose a tooling piece and to hand it over. So after checking with the user again, the robot stamps around the perimeter of the clay. Oops, well, you didn't really see the end of that. Yeah. So the technical and design challenge was to create a dialogue interface which had a simple tree of options. So I used the Alexa developer tools. I could create intents, which is a way for the robot to understand the gist of what the user is saying without needing like an exact word input. So the next version would involve three-dimensional vision of the material, its surroundings, and more of a back and forth collaboration or even simultaneous workflow, working on the same piece at the same time. By building trust in smarter tools, new users can make full use of all their power and precision. Okay, 6 minutes. The following vignettes place the prototypes in a larger context again. These renders imagine how an accessible fabrication commons might be used to allow for people to create objects to suit their particular needs and lifestyles. So you can see the things being made on the left side are then being used on the right. So these diagrams imagine possible interactions between users of the Fabrication Commons. This particular one shows two people living in different cities exchanging information about how to build an interface tool, like the ones I had before, to engage more people in their local community. This interaction is based on a real interaction I had with a student in India who was asking about one of my prototypes because he wanted to recreate it. So this is an example of a differently abled user sharing the hacks with an online community with similar needs. It shows the exchange and modification of designs by community members. And this example shows a person local to the same Fabrication Commons as a user connecting and commissioning work from them. So with these vignettes of people making, learning, and interacting, we can start to form an idea of how a community of empowered, connected creators would look like. Of course, we have to start small to reach that point. So yeah, that's the thesis I completed a year ago, but I've carried through these collaboratist and maker values with me. So yeah, thanks for listening.
Awesome. Thank you so much, Alex, for your wonderful presentation. The floor is now open to any questions from the audience to the presenter. So please just unmute yourself, and if you want, of course, turn on your webcam and ask away. If there are no questions in the meantime,
I see a hand. There's a hand somewhere.
It's a hand.
I saw a hand.
Yeah, hi.
Hi.
Thank you for the great presentation. You started off talking about the transition from Industry 3.0 to 4.0 and how it's kind of marked by this democratization of design. And it looks like, in all these different prototypes, more and more power is given to the end user in terms of actually how the end product is going to look like and feel like. And I'm wondering then if all this power is given to the user, is that power taken away from the architect? And then what is going to be the role of the architect later if everyone is starting to be their own designers and create their own machines? And where do you see the role? How do you see the role of the architect changing, I guess, in this context of Industry 4.0 and this movement of the democratization of design?
Yeah, so this is something I've considered a lot, and I really see the role, like everyone stepping up a level in their roles, where the end user becomes the designer, and then the designer becomes the sort of meta designer. So a person that would create these tools, but also sort of we have every designer has their sort of expertise. So all of that knowledge and skill could be sort of baked into these tools, and then as sort of hidden in the back end, like for example, like restrictions on a material that the end user might not be aware of, and then the tool can say, hold on, the material actually can't do all of that. Maybe try using this or this or this instead. So I think there's definitely still room for designers, and I think it's actually even more exciting, because you get to think of your interaction with users in a sort of different way, where it's collaborative, but maybe not always like one-to-one. Maybe you have to think of it in a more general sense or open-ended sense. Yeah.
Interesting. Very, very interesting. Thank you so much.
Thank you.
Are there any other hands or any other questions from the audience? If not, I'll ask one question I had while watching your presentation, Alex,
Mhm.
and I think the beauty of the research that you've done is really to engage the end user in being a maker. And I think for me, like I saw that benefit of that within the pandemic, especially early on. I think everyone may remember how, at least in Ontario, we were scrambling for PPEs, and there's a lot of a big push for individuals who had 3D printers to create face shields for the hospitals. But I think then, what do you suggest would be the way we implement that kind of maker system for communities or even at a larger urban scale for this kind of idea to be reality?
I mean, yeah, it's sort of what I was talking about, just engaging people in small ways, because I think we're just sort of raised in like capitalistic society where people just think it's like work, make money, exchange money for things, and they can't really see themselves. They don't see themselves as having the power to produce themselves or to work with someone to produce something new. Yeah, and then of course, more practically, like funding and space, and maybe people volunteering their space and their tools to get more people involved. Yeah, but I think it's really interesting to see how the pandemic has I think it has changed people's attitude towards this. Both seeing how like centralized systems fail quickly, like when the boat was stuck in this canal, like such a weird hiccup suddenly, disrupts everything down the line. So that's what I was talking about, the vertically integrated systems. Whereas, I think people, when they're locked down, they pick up new hobbies. I've seen a lot of people pick up new hobbies and then realize that those hobbies could have value to people, like selling baked goods or crocheted things. Yeah. So I think that's the silver lining to the pandemic.
Thank you for that. Looking at the schedule, we are ahead of time, which is great. If everyone would like this, we can take a 5-minute break before resuming at maybe 7:55 to begin the panel discussion with all the speakers. So with that, I think everyone just need a bit of a screen time away from the screen, get some water, maybe use the restrooms, and we'll reconvene back in 5 minutes. Hello, everyone, and welcome back to now the panel discussion part of our Day 1 Symposium. I want to thank everyone again, especially the presenters, for giving their time to Formlab, and to the audience here and presenting the wonderful work that they've done. I also want to thank the audience, too, for sticking on this long. I know we've been on for 2 hours, and so I think we can maybe shorten the panel discussion to maybe 15 minutes, if you guys are okay with that. Yep. Okay. Yeah. So we have some planned questions to really get the ball rolling, and I think looking at it from the I guess high-level view of the panelists that we've invited here today, we have Maya and Alice who really talk about data and how that can integrate into, at least in part one, research in architecture or through architecture, but another part is how we as designers think about the way we develop built forms. And then we see another part in today's presentation how both Jonathan and Alex talk about the end user point of view of design and how do we engage that part. Jonathan talked about different kinds of paradigms in geometry and the way we can rethink the tools we use to help convey the sense of built form to the end user. And for Alex, in his case, I've seen the way we can actually have the end user be part of the maker. So I think given all these very complex and also very engaging topics, the question that we'd like to ask you is, do you think that our society's view that technology and product-driven solutions as a cure-all will hamper the design process? Sorry, let me read this again. Do you think our society's view that technology and product-driven solutions as a cure-all will hamper the process of solving major issues facing today's crises, like climate change and social unrest? Can we tech our way out of these major crises? So I think I will open that up to Maya, who presented first.
Well, thanks for the question. I will apologize as it's kind of bedtime around my neck of the woods, and my kids are probably going to get increasingly anxious in the next few minutes. But I think to answer the second question, or the last part of the question, is no. I don't think we can tech our way out of this, and I think we've seen a lot of examples today, actually, across the presentations, in kind of suggesting that the sort of tech goggle lens, or like a technologically focused lens at addressing and engaging with technology is kind of a dead end or limited. And I think the emphasis today so far has been on, kind of expanding the relationship with technology to be embedded with externalities, to use a term that Jonathan brought up a lot. So I don't really think that personally that I think like technology is the answer, but I do think it's got a lot of ups and positives, and it contributes a lot of potential to solving and addressing a lot of problems. But I think it has to be wielded with great care and thoughtfulness, and I think it's actually really dangerous to not think that way. Something that I've talked about before is like often my work gets kind of lumped in with ideas of like the smart city or something like that. And I think like for me, there's like an interesting idea, and I've talked about it at a recent panel at the school, where there's this idea of like the smart enough city, right? Where you can kind of recognize that, of course, there are a lot of opportunities with embedded technologies. But of course, to what end and how much of it, and how does the kind of reducing the kind of social, ecological complexities that the kind of problems are cited with is a big danger and a big red flag for what the kind of technology-led lens often leads us down.
Thank you for that. Alice, what do you think of that?
Pretty much the same, in a way that you can't solve anything with, not anything, but you can't try to really solve a really complex problem like climate change and all that with technology. It's only your helper. You have to realize that it's just on the side, and you have to understand what it's doing, just like anything else. And before you say, if a solution has advanced technology, it will get you the best best solution, that's definitely not the case. Like you have to think about how it works, what is it doing, what is it really doing in the back end, what does it really provide you. It's just, you just kind of have to think a bit more critically. Yeah. So no, I don't think so.
Jonathan, what are your thoughts on this? Also a no, or would you take the other opposite stance?
Yeah, I could totally be a punk on this one. I was thinking about that, like going the other way, but I'll be sincere. Yeah, look, I think an example. By the way, I'm learning a lot from being in this community that I'm in, and part of why I'm still up here is because I'm learning so much. I'm really learning a lot that I'm trying to pass down to you guys, and it's really shaping the way I think about technology. But just an example is we have enough technology here in the form of vaccines to vaccinate everybody. It could be done in a few days, but we are not there. We are encountering hesitancy and all kinds of funny problems that come about because we're all humans, right? But I think that's the problem to me, is that I again don't want to be mistaken for saying no technology. Again, it's strategic, like the right level of technology, as Maya was mentioning. But I do think the challenge is behavior, and I think for us that does mean we have to learn to understand people and maybe a bit of politics, or maybe just where the opportunities are. I know I feel the same, Alice, but just that's a reality, right? Because I think that's the barrier to a lot of the climate change problems as well. Is the behavioral part. That's what I'm worried about. And in closed circles, I think this isn't really closed, but you wonder. There needs to be some stronger decision making on some topics, maybe in government, or etc.
Alex?
Yeah, I agree. I sort of, thinking about like computational technology and not like chemical technology like vaccines. I think of computers as like just a different form of intelligence. Like it's just a beast that has totally different logic that we won't understand. And it would be dangerous to just let it try to use its logic to solve problems. Like there always has to be the human element to it. I think where it can shine is it can maybe like temper the negative parts of human nature, like greed, for example, because it doesn't have that concept. Like if we say the climate is caused by the greed of some people, you could run an AI that sort of opposes that in a way. I don't know. I have like, I think a lot about like, what would society look like if the like, what's the word? Not politics. Like policy was fine-tuned by an AI to reach a certain goal, right? Like how drastic would it how drastic of measures would it take to reach that goal? Yeah, that's something to think about.
Thank you for that. I'd like to open the discussion right now to any of the audience who would like to jump onto this interesting conversation we're having, or to type in a chat and ask a question of themselves. If not, I think I'd like to ask a second question then, to all the panelists we have here. In thinking about the topic of, okay, so because we've established now, it's not advisable to think about technology as the be-all end-all to all our major crises, but think about more about the negative effects of it. especially relating to architectural design. Do you think that the way architects have embraced technologies hampers the craft and, in a sense, the humanness of design? Or do you think it actually enhances our abilities as architects to provide better solutions to the end users? So I'll open it with, let's change up the order now. I'll start with Jonathan to respond to the question.
Well, I think the answer to all your questions is yes and yes, or no and no. I mean, or yes and maybe no. But I think technology lets us do. This is my point: is you need to be strategic about your use of technology. I think it can let you do some things better. For instance, renderings are amazing. They're amazing. I mean, everyone loves it. They're amazing. And so our rendering software is incredible. It's gotten so much easier. I learned a program called Form Z in first year at Waterloo, and I spent a week trying to make one rendering, and now you guys, or even my AE students, like, anyway, Lumion is like, whatever. So amazing. But I think there's a downside also, which is that that I've seen in practice, which is that we've gone from intelligent 10-page drawing sets in the 20s to 300-page drawing sets where we're expected to have a 3D model, we're expected to have a render, we're expected to have all the schedules, we're expected to have, and I think that's a runaway. And so again, I think it really screws us in practice. So I think we need more resistance. Maybe not to say no, but to say, yeah, and this is what it'll cost. So I think the positive is that it's amazing. The downside is that I think that we can quickly be expected to do more and more and more and more and more. And we're not thinking very well as a discipline about the cost of that extra work. That's my feeling right now about technology.
Yeah, that's very interesting. Maya, do you have anything you'd like to add to that, or any other counterpoints?
I mean, I guess I'll just say that I think the testament to the people on this panel and the way you guys have organized it's technically a talk about, architecture and computational tools, perhaps. But Formlab has that just general umbrella. And here we are talking to a group of people who use technology, who know how to do it, but who are resisting, I think, a kind of singular version of what it is and using it to advance agendas in all sorts of areas outside of parametric formal expressionism, right? And so I think the answer is kind of on the panel that, of course, it can be used to not limit the craft or the ambitions or the, be they social, ethical, cultural, whatever. And it's just, I think, a matter of, to be honest, like building enough of a foundation in this stuff that you're not just copying and pasting, scripts to do what others have done with like tweaking one variable, but you're kind of building up sort of bootstrapping capacities and bottom-up abilities to actually harness the tools, because their true power actually is in you becoming the author of the tool, right? And that sort of allows for new access, new groups. You're not limited by somebody's preconceived notion of what it should be and all those things. So I think that's the part that's really exciting to me. And for anyone who's taken like a course with me knows that I really resist. Like Grasshopper is great. I use it all the time, but I really resist that being an introduction to kind of computational design because I feel like it's too enchanting to be mesmerized by its effects without actually having the discipline to control them and plan them and implement a plan, rather than being hijacked by what they offer. And so that's an important line, and I think that's a responsibility that, as an architect or as an educator, you should think about where you fall on that line and how you use technology.
Alice, what are your thoughts on this?
I guess I'll jump a little bit slightly off topic, and just talk about the tech of BIM in terms of craft more so. It's something that's very much hindering in like the early stage process when you work with some of the softwares and try to work in that logic, and try to design something. Like the formal constraint is quite obviously there because of the way the logic works in the background. But BIM works so well with Excel and how things will work in the long run. So it's one of those tools. It's like a yes and no to your question. That's not that great for crafting a building, but it's been great as a starting point for us to start understanding how information in that virtual realm works and how that will connect to like a management perspective after construction. So that's something when it feeds into digital twin and into real life. So that's like a fully different process. And that actually uses a very different logic than how we design and how we think about sketching. And kind of going back to when Jonathan mentioned that we are now producing like 300-page drawing sets, has been very much because we are able to do BIM and just generate them really quickly because the information is just there. Yeah.
Alex, what do you say to that?
Yeah, I agree with everything. The interesting thing with the like 300-page thing is that like with BIM, I mean, I think like drawings in the traditional sense might become obsolete, and then this is now like an awkward period where we have to translate like the BIM model, which is essentially like a virtual copy of what will exist into drawings, and drawings are like representation of a small part of the building. So maybe in the future you'll have contractors and tradespeople just like putting on goggles and seeing where they're supposed to put the brick. And then drawings will be a thing of the past. And I just want to reiterate Jonathan's slide of the parametric design Google image thing, where like that's just a leftover of like the 90s where people were super excited by this technology, just to make formal things that are so hard to make. But like I'm more excited about how easy it is to make like a parametric piece of millwork that'll shift everything automatically and fit the space in like seconds, and then you have like ready to go shop drawings, which isn't as flashy obviously, but it's cool that you can invest some time and then it'll pay off. And then of course we have to learn how to take advantage, like as architects, of this extra value. Like all this extra value can't go to the client. We have to take advantage of it too. Yeah.
I think we have time for one more question. Before I ask it, I'd like to give the audience another chance to join in this conversation, and raise their mics and ask a question, or to post a comment in the chat about what we're talking about right now. If not, I'd like to bring attention to what Alice actually has mentioned, the notion of the digital twin. And I think for me, that's quite interesting. The first time I actually saw about it, I don't know if you guys has stumbled upon it, the B1M and Unreal Engine had a recent, I guess you can call it their own symposium, where they talked about the digital twin and the advancement of not only game engine rendering engines emerging into the AEC industry, but also the way to actually replicate to the T built designs that would actually embed themselves into discuss real life looking model of reality. And if we're talking about today about being, I guess, kind of summarize it, a slight hesitancy or caution to the way we apply these digital tools and being critical about them. What are your thoughts about the movement towards this kind of development system, the digital twin, which seems to be taking some big advancements, especially in the master planning there's this city in New Zealand, I forgot the name now, where they implemented digital twin to actually plan out any future development of the city. I will let it open to anyone who wants to start first.
I mean, I'm happy to kind of offer some opinion on especially the case at the scale of the city. The idea of a digital twin is absurd for me. I just think that as maybe emphasized in the work, and maybe again picking up on the idea of like externalities from Jonathan, by definition you're building a model of something. And by definition, when you're building a model of something, you're abstracting the real thing to build the model. And so there's actually like you have to be aware that you're kind of taking as a set of conditions as an assumption and prioritizing, just like Alice was asked, how did you score the importance in her adjacency matrix and things like that. Like, you're making assumptions, and yeah, they can be measured, but they're the depth of the externalities, and to kind of understand that and model that and capture that in a model that doesn't screw it all up anyways is kind of next to impossible. Like, as humans, we can handle 2 or 3 variables, and sure, computers can handle multiple dimensions of information, yet you still need to kind of author the sort of the base condition of that model. And I think it's dangerous to think that it's all encompassing, and it's dangerous to think that it's a true representation of the city as a twin. It might be effective and useful for something, but you always have to be aware that it's actually a constructed entity that is full of bias and other kind of elements that need to be held in check or evaluated.
I think there's a lot of misuse of the word digital twin in some ways. Like, when it applies to a city at this scale, you're really just looking at a virtual model. You're not really working with it as a digital twin. Like a true digital twin in concept, you kind of have to think of it in like an MEP, a mechanical kind of way. Like, you have modeled the conditions and loaded in parameters of like your air conditioner, and you know that when something breaks, it's connected to the system. So then you know that in a few years, this air conditioner needs to be replaced. So these are the kind of the little detail that's embedded in the twin. So then the physical conditions that is in the building, the elements, are being tracked by a monitoring system on the back end, rather than saying it's just a virtual representation to the dot of what you're building. That's not that's just what's visible. And again, yeah, there's only so much parameter you can prioritize. Like, it makes sense from an MEP perspective, but from like a human perspective, what should be tracked of a building? What should we track inside a space is really questionable.
That's a good point.
I'll jump in. Christopher, thank you for also these questions. They're great. I mean, in a way, you need a weekend. You need a weekend. I think there's a link between here. I'm going to try to make a link between just our discussion of the digital twin and this discussion of the growing drawing set, the 10-page versus the 300-page drawing set. I actually think, and I'll argue against Alex. I'll argue for the need I totally believe him. I think we're going to be passing models, but I think there's still a use for drawings. I think that plan sections elevations are control rigs. I mean, you can talk about them in a nerdy way and they sound cool, they're control mechanisms to guarantee a certain focus on a set of relationships. And I think they change the level of abstraction. They're a lens to abstract a thing so that you're only looking at a certain subset of relationships, much like the digital twin in Alice's description needs to be an abstraction of the city and can focus on certain other elements, right? And I think that, I don't know if you guys have noticed this. I've seen it, I think that it's in an engineering school where I teach, it's really hard to teach plan section elevation because there's no one else around you, that we kind of have this baggage. We take it for granted that those things are important. But if you're thrown into a world where kind of we think that all you need to do is build the model, it's I see the quality, the work change, the output of the work is different when people rely on the model. So your tool or your abstraction mechanism does impact the work. Back to tools not being neutral. Tools are not neutral, and so building a building in section. By the way, the manual of section is this new LTL book. It's PDF. I think they've released it for free on Issue or something. You know, you'll look at a bunch of beautiful buildings that were built in section. I think that's a thing, so I wouldn't want to lose it. And I think it's our thing in a way. Like, I think it's actually very hard. In engineering, it's a cut. I think to us, it's a section. And I think for us, the section is a control mechanism that abstracts certain relationships. Yeah, and I think if you need that, I think Google Maps has it. You need to abstract to understand and to control something.
Mm-hmm.
Alex, we haven't heard any thoughts from you yet. Would you like to add anything?
I can add on. I sort of forgot where this tangent led us from the original question, but yeah. For the abstraction versus what was not the image of the building, the duplicate, whatever that word was, twin, the
visual twin.
Yeah, I think maybe using different tools for different things. So like a representation for us, abstracting representation for us when we're designing, to know the quality of the space. Maybe we do something different to when you're already finished the design and then you want to communicate to the person that's actually going to be building it, right? Maybe those can be two separate things. I don't know. Because drawing set is a set of instructions essentially, and if you've done a good job designing the building using abstraction, it'll be built this way with accurate documentation. Yeah, I don't know. That's sort of what I was thinking.
Thank you for all that. Thank you everyone for your comments. I think we'll end the discussion here unless anyone else has anything else they'd like to add before we sign off and say adieu to each other. And I understand it's late. Oh, we have Simon. Hi, Simon.
Hey. Yeah, I just have one comment to make. I know it's getting late, so and maybe it's opening a can of worms, but it's really related to the comment that Jonathan, you made early on about the 300 page, the 300 drawing set versus the 10 drawing set, and also just like the need for people to like start saying no more, and just kind of put the brakes on this automatic production of things without too much reflection. I'm seeing that it's like it seems to become an increasingly alarming problem, especially related to this idea of climate change and the responsibility that we have as designers and other design professionals have with regard to, I guess, where are we going? Like, what does the future look like for us? And there's a law in, or I don't know if it's a law or just a principle in economics called Jevons paradox, and I encourage anybody to look that up. It's essentially it's the idea that any process that is made more efficient eventually becomes it gets to a point where resources are consumed beyond I'm kind of screwing up the wording here, but
like to match the new like to match the new pace of it. You're saying like more resources will be used to
or more efficient process becomes, eventually it just it speeds the rate of depletion of that resource. So that's the Jevons paradox, and I think it's particularly relevant for us in architecture with the climate crisis. And I guess if I have a question surrounded about that, it's just like, how do you guys perceive going forward with technology if it just keeps going, if it just becomes more efficient like that? Or I guess should we place our efforts on trying to make things not more efficient, but like put technology towards quality instead of quantity here? Yeah, I'm going to stop it there because I think there's a couple questions I could have about that, but I'd be interested to hear your thoughts on that, please.
I mean, I have something to offer just along those lines, where I actually think that, the kind of performance-based metrics and objectives that we often see, for obvious reasons, like they're typically the easily quantifiable ones, and they often start to be our measures that we pick for, and then also what we target through our technological deployments. And I think it's really exciting to think about technology outside of those kinds of performance metrics and think about, sort of subverting those ideas. And there's like a lot of interesting people out there, like Mark Shepard is a kind of interesting fellow who, who's kind of using technology, but rather than giving you the route from point A to B, that's the quickest, he might give you the route from point A to B that's, most likely to give you a moment of delight, whatever, or the one that you're most likely to encounter a friend on, or whatever, right? And so I think it's interesting that while those performance efficiency metrics are kind of baked into how we relate to technology and the concepts and the targets and the modes we operate with it, they're certainly not actually predetermined as the only ones.
Yeah, these are all such good questions. I'll also say, Simon, I don't know if the question's that clear to me, actually. I'll answer it, but I don't know if technology, if we can just talk about it that generally, as something that's racing. I think it's streamed. I think that maybe there's a particular, like, rendering or door sketch or like BIM or performance modeling. Like maybe I could give you a better answer if it was in one of those troughs. But just generally, I think we shouldn't be. I think we have to be pro-tech. I think we're pro-technology. I mean, at least I'm pro-technology. I'm just like pro-selection. And down the lines that I was actually thinking the same kind of environmental psychology lines as Maya. We have a colleague, Colin Ellard, in the psychology department who's looking at the use of sensors to try to understand people's experience of space, for instance. And I think as technologies improve, we'll be able to use high technology to help us quantify the value of different aspects of the design quality matrix and kind of maybe ask clients to pay for that. If we can prove that we'll put a little extra time in and this space will make you less anxious, that might actually end up having a value if we can measure it. So I don't think it's all bad, but I think it depends. It depends on the trough.
Yeah, I do admit there was some cynicism coming from that question. And I guess I'm not going to go on any longer. I think it's pretty late right now, but yeah, thank you. I don't know if Alice or Alex had any thoughts.
I think it's really clear to see like where the downfall is with automation, because that's changed so many industries so quickly, and you can read about how years ago people are excited about oh, well, this is going to save us so much time and effort, and everyone's going to be working 3 hours a day. But yeah, all those benefits, everything's all that value and wealth is being centralized. So I think the failure there is, again, like negative side of human nature. Yeah. So in an ideal world, that new value would be distributed, and then everyone's quality of life would increase. Yeah.
I'll make this quick. I agree.
Great answer. Simon, I want to thank you for really asking really hard questions today. Yeah, thank you for those comments too. I think that we'll wrap it there with your last comment. I want to take this time and say that, from my bottom of my heart, thank you to all the presenters, Maya, Alice, Jonathan, and Alex, for donating your time and coming here tonight and really engaging us with this exciting conversation about architecture and technology. I think the lesson for us is really there's a huge benefit to be critical about the tools we use, and also to be aware about when to be critical and also when to say, yes, we should adopt it. I think that the more we talk about it, the better we'll have as our school, but also as a practice to understand when should we use technology and to solve what problems we want to address. So I think I'll leave it at that. I also like to thank, I know they're not here today, but Amy Townsend from the School of Architecture who helped us publish this event, Andre Jignat, who has supported us through IT, and of course, all the Formula members who have helped plan this event to make this a possible reality. And of course, last but not least, I'd like to thank the audience for taking the time today to come out and join us on this exciting conversation. And I look forward to seeing everyone again tomorrow at 6 p.m. Eastern Standard Time for the second half of our symposium. So with that, I think we are done for tonight. I know it's a long day, but it's been really exciting and great conversations, and thank you all.
Thank you. Good to see everybody.
Thanks, everyone.
Thank you.
Have a good night.
Good night.
Thanks, everybody. Thank you, Chris.